Good day, everyone. My name is John Mark Angelo Lingon, together with my partner Kenneth V, Tamomoc, and we are here to present our thesis entitled Analysis and Prediction of Land Cover Change in Sierra Madre, Philippines using GIS-based or multi-perception neural network. Let's begin. Sierra Madre is considered as the longest mountain range in the Philippines as it includes the province of Cagayan all the way to the Quezon province. Land cover changes are happening, and this is not ideal to areas like Sierra Madre. Imagine Sierra Madre is a mighty warrior and its land cover as her armor. Without her armor, we would be vulnerable to incoming typhoons and floods, and biodiverse endemic species of plants and animals would lose its own. Besides, it is served as the backbone of Luzon for being the strongest natural defense against typhoons. For instance, Super Typhoon Parding, also known as Noru internationally, recently made landfall in the Philippines with wind speed of 125 meters per hour. Even though this super typhoon is very powerful, it seems to lose some of its strength as soon as it made contact with the Sierra Madre. But despite its critical relevance to humanity and the diverse biodiversity present in Sierra Madre, this natural resource area is undergoing rapid changes. For this reason, in our thesis, we aim to analyze the land cover of Sierra Madre from years 2000 to 2020 and its relationship on the environmental and socioeconomic drivers, and provide a 10-year and 20-year land cover forecast of Sierra Madre. In line with this objective, in our research, we would like to know the land cover status of Sierra Madre from years 2000, 2010, and 2020, as well as the land cover area change in Sierra Madre between years 2000 to 2010 and 2010 to 2020. Also know the strike of association of land cover change on the following environmental and socioeconomic variables, such as elevation, distance to road, river, and cities, and the population. Lastly, to know the 10-year and 20-year land cover forecast of Sierra Madre by utilizing GIS-based MLP neural network. But how? How will this be achieved?
This framework shows the overall process that the researchers take in order to analyze and predict the land cover change of Sierra Madre. As soon as the data is gathered and reclassified, it is then imported into the Terset software, which is the sole responsible for making the land cover prediction happen. It has complete feature that is necessary for forecasting the land cover change in the next 20 years. The validation of the maps in order to have the kappa value and test the accuracy of this value are generated through Idrisi GIS analysis under Terset as well. The interpretation of data and findings. The land cover status. This graph right here shows the amount of change in area of each classifications within the 10 years interval. Agricultural land and others are observed to be continuously decreasing as the years progress, while the forest area starting from the year 2000 to 2010 is observed to increase a bit, but later on from 2010 to 2020, it starts to drop as well. And on the other hand, the urban area constantly dominates as it shows a continuous massive increase in area as the year progresses. The gains and losses in 2000 to 2010 shows the gains and losses of each classifications, and despite agricultures and others having some gains, the number of losses in the area unequaled it, while the forest area has a little fraction of gains as compared to the losses between these years. And when it comes to the urban area, it can be seen that there are no losses and only gains. That's why this classification resulted in a vast amount of area change. The transition from 2000 to 2010 shows the transition of the classifications, and one of the major transitions that happened during these years is agriculture to forest and forest to agriculture, indicating that there is a slight gain in terms of forest despite the loss it has, in line as well in the gains and losses of the same year in the previous slide. And the other major transition is between agriculture to an urban area, which only shows why urban area manages to continuously expand without getting any loss, as there is no transition recorded of urban converted into agriculture, forest, and other class. The gains and losses in 2010 to 2020 indicate that agriculture, forest, and other have great losses as compared to their gains between these years. That's why the rate of change in the area of these classifications are all decreasing. While on the other hand, the urban area manages to increase even though there is a slight loss between these years. The transition in 2010 to 2020 shows a massive change between forest to agriculture and the great transition between agriculture and to the forest, which shows that a large portion of forest is being converted into agricultural land. Another huge area of transition is between agriculture to urban, showing the high potential of using it as people's shelter is what comes next to agriculture.
Using the pre-processed images of water variables and reclassified land cover images, the researchers performed a special correlation using ArcGIS. The researchers have found that the elevation, distance to river, and cities projects a moderate negative correlation to the land cover. This indicates that as the proximity of the variables gets closer, the land cover decreases or vice versa. For the population, it projects a negative 0.85 correlation coefficient, which shows a strong negative correlation with the land cover change, meaning that the population has the biggest contribution to the land cover change compared to the other variables. And since it is negative correlation, as the population increases, the land cover in return decreases and vice versa. Lastly, the distance to road, on the other hand, with the negative 40.47 correlation coefficient, shows a weak negative relationship with the land cover. This indicates that the relationship between the two is weak, but this does not mean that the correlation is insignificant. Overall, both the environmental and socioeconomic variables shows a significant relationship with the land cover of the study area, meaning that the set environmental and socioeconomic variables indeed has an influence with the land cover change of Sierra Madre mountain ranges. Next we have is the validation and transition potential modeling. The researchers used the MLP neural network approach for transition potential modeling and prediction. The researchers employed the land cover data from 2000 to 2010 along with the environmental and socioeconomic variables to project the land cover map for 2020. The projected land cover map were validated by comparing it to the actual 2020 land cover map. The projected map of 2020 obtained an overall kappa index agreement of 0.9569, indicating that the projected map of 2020 was accurate when compared with the actual map of 2020. Same study by Ngoy et al. Has projected the same accuracy rate using MLP neural network for prediction. Their study projected a 0.93 kappa index agreement, and this only proves how the utilization of MLP neural network is indeed useful and reliable for prediction of land cover of an area. In line with our SOP number 4, the researchers have predicted a 10-year and 20-year land cover of the study area, which were divided based on the classification. It has been found that, as the figure shows, the agricultural land in the study area will continue to decrease significantly for the next 10 and 20 years. According to a study conducted by Brandy-Amor et al. 2017, in Asia and Africa, Asia will have the most absolute loss of agricultural land, which is 80% of the global agricultural loss, and it will completely lose agricultural lands due to urban expansion. Just like the findings in the land cover change of 2010 to 2020, it is possible that mostly of the agricultural land will be converted to urban area by 2030 and 2040. For the forest area, as the figure shows that in the next 10 years, there will be a significant decrease in forest cover and will gradually increase for the next 10 years after 2030. As seen in the previous findings also that the forest cover really tends to fluctuate as the years progress. This findings is supported by a study of the Annuncio et al. 2015, which suggests that for the next 15 years, from 2015 to 2030, the global forest region is expected to decrease. At 2030, the rate of natural forest loss continues to drop by 0.26% per year to 0.98%. Even though there will be an increase in forest area by 2040, the loss from 2030 is still greater than its gain, which is an indication of deforestation. For the urban area, the figure shows that after 2020, the urbanization will continue to increase for the next 10 and 20 years. And by 2030, the urbanization is expected to increase by 36.28%, and this is expected to increase for 13.42% more in 2040. According to a study by Seto et al. 2012, the urban expansion is expected to continue. It is expected to rise by approximately 1.2 million square kilometers, which is almost triple of global urbanization in 2000. This shows that the urbanization is expected to expand rapidly as the years progress, which is not ideal to places like Sierra Madre. Lastly, the others. As shown in the figure, the other land cover class will increase significantly by 2030 and will continue to increase by 2040. These land covers include shrublands, barren lands, and water bodies, etc. So there is a chance that the losses in forest and agricultural land will transition to barren land, which means no vegetation or water bodies, which is not ideal to Sierra Madre also.
In conclusion, the researchers generated 7 findings in this study. First is, as the age progresses from 2000 to 2020, the urban area continues to expand while agricultural land, forests, and others continue to significantly decrease. It is possible that the biggest contributor to forest and agriculture change is urbanization. Second is, between the years 2000 and 2010, the urban area and forest area have gained more than the losses, while agricultural land and others, on the other hand, have lost more than they gained. The third is between the years 2010 and 2020, the urban area continuously gained more with a larger growth rate, while forest areas, agricultural land, and others have significantly decreased, and most of the agricultural land transitions to urban areas. The fourth is both the environmental and socioeconomic variables shows a significant relationship with the land cover of the study area, meaning that the set of environmental and socioeconomic variables has effects on the land cover of the area. Additionally, the closer the proximity of socioeconomic variables to the Sierra Madre, its land cover to decline. Fifth is the evaluation of the projected 2020 land cover map with the actual 2020 land cover map shows that the utilization of Terset's land cover modeler and integration of MLP neural network is useful in predicting land cover in the study area. The sixth findings is the projected maps for the years 2030 and 2040 indicate that agricultural land is expected to decline over time. Forest cover will significantly decline during the next 10 years from 2020 and is expected to significantly increase by 2040. By 2030, there will be a 36.28 growth in urbanization, and by 2040, there will be a 13.42 increase. Lastly, it is anticipated that the other land cover class will grow significantly by 2030 and keep growing until 2040. The outcome of this prediction is with respect to the environmental and socioeconomic variables, meaning that if these anthropogenic drivers continue, there is a high chance that this prediction may happen. And the last findings is of this study can be utilized to aid policies aiming at maintaining and conserving the Philippines' environmental resources, as well as standard guide to further protect the and conserve the area.
Just like what DNR Environment Secretary Royce Mato said, prioritize the protection and conservation of Sierra Madre. Saving this mountain range is equivalent to saving the lives of many people from damage and destruction brought by natural calamities. Thank you so much for listening. We are now open for questions and suggestions.